Hello, my dear friends. Welcome back to my YouTube channel. So today will be an interesting tech video channel. Okay, as you can see from my screen that I am trying to set up Kubernetes on bare metal, and I will use KubeADM, kubectl, and kubelet to do all of these things. Okay, so this is just a prototype that it might be that there are other people who are trying to do this, and I've seen lots of resources and videos too. But the only resource that I will be teaching you guys is that read through the documents of Kubernetes. Okay, what it is telling you to run, the instructions that it is telling you to install, the packages, network configuration, everything that will be there. So by following this video and only this video, I will also post a step by step procedures that I have taken. And by following only this documentation and some of the GitHub profiles of installing Flannel as a network configuration, as well as container runtimes, the ports and protocols that are given over here to open them on the control node and worker node. Okay, so these things I will be following all through these pages, and I have made a significant amount of notes that I have kept it over here. Okay, and I will be sharing it with you all guys. So I will be following this procedure and will be telling you that how by following just the resources step by step you can set up Kubernetes on any local machine or bare metal or even on the virtual machines that you have set up on public platforms, platforms, that is AWS, Azure, or GCP, and you can literally manage it on your own. Now, the most basic difference that I have seen in other videos as well as in other references that they are trying to do it was lots of uh, basic level of configurations or how to do or the reasoning behind that why did they do this was lost. So even if you are a basic Linux operator or basic Linux commands, then also you will be able to do this. Okay, now again I will emphasize on this fact that you should go with the procedures that is written in official Kubernetes document. So yeah, let's go. So first of all, we know we need a machine. That's it. So right now I won't advise you on the fact that to install VirtualBox, okay, Oracle VirtualBox. Then on the top of it, install some Debian or RHEL. That is, what is it? RHEL, Red Hat Enterprise Linux, or any Linux on it, and corrupt your system. Or maybe you are not having so much of memory power or CPU or core in your own laptop or local machine. So I would highly advise you to follow the what I am following over here to make virtual machines on the cloud. Okay, one for control plane node and two for worker nodes. So the thing is, we all know you can also search it over here on the Google. As you can see that I'm trying that the uh, Kubernetes components diagram, what is there in control node as well as in worker nodes. So you can see from here that basically we need five components of Kubernetes on the control plane through which that node is going to control your worker nodes on which the pods or services are going to be implemented. So I won't go into the basic of this. You can read this and you can take the reference of any courses. There are many lying on the YouTube. Okay, so yeah, these are the five components that are must be installed, and based on that the network configuration going to be installed on the virtual machine that will be playing the role of control plane. So that is Kube API server, HCD, Kube scheduler, Kube controller manager, cloud controller manager, and in the worker node components, that is the kubelet, kube proxy, container runtime. Okay, so yeah, let's go and figure it out on that. Okay, let's first go to the cloud. I am using AWS, my own IAM user account, and we will be utilizing this only. So yeah, so first let's we have to ensure before you begin, you need to make sure of these points. Okay, you need to have a compatible Linux host, not Windows, nothing like that. That will be Debian or Red Hat. So here I will be utilizing T2.medium because it has around I think 4 GB of 8 GB of RAM as well as two core CPUs. Okay, and all the specified configuration matches in them. Okay, then you can go over here and install all these things. So let's begin it. Okay, so what I'm going to do over here before going through that is to make sure, as I'm going to launch these control plane and worker nodes on the AWS virtual machines, I want to make sure that these required ports are open, and this we can make sure by making security groups for that respectively. Whether now, if you are utilizing virtual machines over cloud, you can utilize firewall rules for GCP, Google Cloud, and I think there is already security groups also for Azure virtual machines, so you can utilize that. Yeah. So let's go on the okay. This the required ports. When you click on here, it will open this page only. So let's go on it and let me close this tab. Yeah. So these ports we need to make sure, so we can make sure by creating a security group over there. So okay, so now I am in AP Southern. I am an Indian, and this is the most nearest availability zone from my home or local hometown, that is Asia Pacific, Mumbai, AP Southern. So I will be launching over from here. Okay, and you can choose the region based on you. What happened when I think I changed it, right? Okay, no worries, let me change it back to AP South one. No, man, no, no, I don't want to be in Sydney or anywhere else. India is good enough for me, and I don't want to be making videos by another yacht, but can't help it. I need to make this video. Okay, so we are in the security groups. Okay, we need to create two security groups over here. Okay, one is for the worker node and one is for the master node. So here I will be utilizing two EC2 instances, T2.medium one for the worker nodes, and one wall will be for the control plane node. So let's create it. So let's name this control plane SG security group. Okay, and describe it as the security group. Wait, where's the spelling? Okay, yeah, I get it. My English is not bad that much. So security group is for control plane or master node. And yeah, one more thing, be clear that what are the IPv4 CIDR ranges. Now, I don't need to explain this. You already knowing about some networks and CIDR, how they are configured and all these things. So this is the default VPC. It will be available by default in your own region. Okay, so be open that page, and just for the reference, you just see that these are the subnets that are there. Okay, referencing other each availability zone, AP South 1, CBA. Okay, so let's go over here. So it's the same is selected over here only by default. Okay, now let's add inbound rules. Okay, so these port ranges are on, you need to make sure these are open for control plane. These port ranges are open. Why? Because look, every component of these Kubernetes interact in some or the other way. Okay, through the network ranges, and these ports needs to be open so that they can communicate with the pods or everything that is being controlled by the master node. Okay, so let's open them one by one, and we can see these all details are already given over here, so you just need to configure it accordingly. So let's go on the control plane and custom TCP. Let's open this for 6443. Now right now I am utilizing anywhere IPv4. So okay, but when you are establishing it for your production or on-premises servers, you need to customize it according to your, let's say, subnet, private or public one, whatever the CIDR you have configured it. So if you're providing it for custom, let's say my subnet, maybe let me choose it AP South 1B, 1A, sorry. Okay, and the CIDR for this is 172.31.32.0. So you can specify this. Okay, that any IP is not going to, you know, get it. So you can see over here that slash 34. So this, the set of these custom IPs are only going to be permitted to make this call. Okay, slash 20 and dot 0 slash 20. So you can utilize this like this. So this particular security group will be attached to the control plane. What does it mean is that only the specific amount of IPs that are in AP South 1, this last one, AP South 1A, are going to be permitted to access the 6443 port range into your master node. That's it. Okay, so for now I will not use this. I will use anywhere IPv4 just for the security, not for the security, man. Like, I want to really be open and let the Kubernetes interact with themselves, like master node and worker nodes. Okay, so let's now add rule, another one. What was that? 2379 to 2380 for Kube API server and etcd. Do I need to explain this? No, I don't think so. You can get it plenty of videos to explain it what Cube API server and etcd does. Again, let's open this 10,250. 10,250. Yeah, done. What are other 259 and 257? 10,259, 257. Are these the ones? Yeah, View Controller Manager. Anywhere IPv4. Now, one more thing you need to do over here, you need to add SSH so that you can log in through your, maybe I am logging from a WSL to Ubuntu distro. Okay, that is already installed in my system. You can use Putty, Mobile System, whatever the tool you want to SSH into your these instances. Okay, one more rule I will add, that is all traffic for now, so that at the end when I will be deploying any, let's suppose any app or maybe nginx, so that I can you know I can access those app or nginx via the IP of this master node or the instance that I will be attaching the security group to. Okay, I think all are done over here and outbound rules are good. Custom it is there. Yeah, so let's create the security group. If anything goes wrong, then yeah, we will debug it on the go. All right, one security group has been made, and you can verify this port range and custom TCP is set all according to the details given over here. Now let's create another security group from here. No, not from here, from here, for the worker nodes. Okay, and we will name it as worker node SG, that means security group, and define it as anything, security groups for worker nodes. And let's define the inbound rules for this as well. This is much easier. There are only three TCP protocol, sorry, three TCP port ranges that you need to define. So one is 10,250 for kubelet API. Kubelet is the one which lets your pod interact within themselves, and it's much important. If there won't be kubelet, you won't be able to do anything. Then another is 256. Then add rule 30,000 to 32767. That is the limit in any one instance, I think. 767. And yet again I will define rule for SSH for now. Okay, anywhere IPv4 and all traffic, so that I can pinpoint if my at the last of the video if I am deploying any web application, sorry, all traffic, any web application or nginx, so that I can access through the public IP of those instances on which this security group is going to be applied. Okay, all right, let's go create security group. Okay, both are being made over here, where it is. Yeah, you can see all are being made over here. You can define, let's see the details. Okay, this is the worker node, and you can see the inbound rules for here for checking here. Let me make it bigger for you. Okay, so this is all clear, and simultaneously it is all good. Okay, so yeah, now after this we have to launch EC2 instances, right? Now let's go and launch instances one by. So I am selecting t2.medium.